Another key dimension that we use to describe engines is the compression ratio of that engine. So when we think about engine operation, as that piston is going up and down, at some point there's going to be a compression stroke where we take whatever gas is in that piston and we're going to compress it. And the amount that we compress that is very critical to engine operation. And we'll see this a lot later on when we talk about different fuels and how we ignite those fuels in there, and the pressures can get too high and cause us problems, or if they're not high enough, maybe they'll cause us problems. And so that pressure, how much that gases are compressed on that compression stroke of that engine is really, really critical. So we need to understand that dimension. We need to be able to calculate that and understand what it is. So let's talk about the compression ratio. The compression ratio is the amount, the ratio, the amount that stuff is compressed. And it's a ratio, so there's going to be two different numbers. So what is that compression ratio? And I'll write that down here. I'll write CR for us to start to understand this. So the compression ratio is a ratio of the total volume that we have up here, the total volume, divided by the compressed volume. Total volume divided by the compressed volume. So when we look at our piston drawings over here, we have the piston on the left at TDC, or top dead center. We have the piston on the right at bottom dead center. And what we're looking at is the total volume, and it's going to be at, and I'll write that up here, at bottom dead center, at BDC, just so that we're clear about that. So it's the total volume when the piston is all the way down. That's when the volume above that piston is at its maximum. It's a total volume. That's as big as we can get. That's a maximum space that you're ever going to see above that piston. Okay. Now, when we compress that, we're going to compress it up to this volume over here. So this is the compressed volume at top dead center. Now, we have a name for that, and we talked about that. That volume, when the piston is all the way at the top, we said that was our clearance volume. Our clearance volume. So that's our clearance volume up there. This is our total volume down here. Now let's think about that total volume on this side, because there's really two components to that. So I'm going to draw this line across there that I did before when we looked at the displacement of the engine. And this total volume is really comprised of two different things. It's comprised of that clearance volume, which is the same as we had on the left, and this volume down here we talked about before, that is my displacement of the engine. So I can rewrite this equation as the total volume, or the volume at bottom dead center, is two things that we know. It is the displacement of the engine, DISP, plus the clearance volume. These two volumes put together. So it's plus the clearance volume. So I'll write that as CL, or abbreviated as CL, for the clearance volume. So it's the displacement plus the clearance volume divided by what is the volume at the bottom, or the volume at the top, our minimum volume, that is the clearance volume. So it's divided by the compressed volume at top dead center, which is the clearance volume. So this becomes our equation. It's the total displacement plus the clearance volume. That's everything that's above this piston at bottom dead center, divided by the compressed volume, so which is the clearance volume. It's the same thing as the clearance volume above that. So that's our equation. So now we can use that equation to calculate some different things. So let's do some examples and get some practice with this. So our first example, we're going to find the compression ratio in an engine that has a displacement, so we're given a displacement of 12 CI and a clearance volume of 8 CI. Oh, shoot, here we go. Some other weird units. What are these units? Oh, this is something, again, that you'll see in literature. Sometimes you'll see literature abbreviate measurements like this. CI stands for cubic inches. So I'll write that down here. It's a cubic inch. CI is cubic inch, like CC was a CM. So sometimes people will say CI instead of inches to the cubic power. It's easier to type, I guess. And over here, this is also cubic inches, 0.8 cubic inches. So now this becomes a relatively easy problem. So we can say that our compression ratio, CR, is equal to, and then my equation is the displacement plus the clearance volume divided by the clearance volume. And that is equal to, what is my displacement? 12. And I'll write my units down here. Keep my units with me. 12 cubic inches plus my clearance volume is 0.8 cubic inches divided by the clearance volume, which is 0.8 cubic inches. Now, if I plug this into my calculator, and I've got to be careful on this, when I'm doing these kind of problems, when there's addition and multiplication, that I get my order of operations correctly, the My Dear Aunt Sally, or however you remembered that. But you got to add these two together first, so you have to add the 12 plus 0.8 first, and you get 12.8, and then you divide that by 0.8. So make sure you don't do the 12 divided by 0.8 and then add 0.8 or something like that, because your answer will be incorrect. So add these together first, and then do the division on there. So if you calculate that out, add them together, divide it out, you're going to have a number of 16. Oh, now every time we do one of these problems, we say 16 what? What are the units of that? So let's look at this equation. I have cubic inches and cubic inches in the numerator, but they are added together. When I'm adding numbers together, first of all, they have to be the same units. If they're not the same units, I can't add them together mathematically. The equation is not going to work out correctly. So those have to be the same units. So they are the same units, but that doesn't change the unit when I add them together. That means that a cubic inch plus a cubic inch is still cubic inches. So I'm taking some volume, adding some volume to it, it's still volume, and that is still cubic inches. So the total, or the whole unit from that numerator, is cubic inches. What units do I have in the denominator? I have cubic inches. What happens when I have cubic inches divided by cubic inches? I end up with nothing. They cancel off. So it becomes unity or whatever. So the answer is just 16. Now what we often will do is we'll write this as 16 to 1. We'll do something like that. So we'll put a colon in there, and we'll say that that compression ratio is 16 to 1. So what is that saying? That's saying that that total volume, the big volume when the piston is all the way down, is 16 times bigger than the volume of the clearance volume of that compressed volume when that piston comes all the way to the top. So we're compressing that volume by an amount of 16 to 1. And we'll find out later that that's a relatively high compression ratio. So that's something that you might typically see on some higher compression engines, like some diesel engines or something like that. So spark ignition gasoline engines will typically be on the order of 6, 8 to 1, maybe 10 to 1, something like that. So those are typical numbers. Now if you're doing your math and you start finding compression ratios of 150 to 1 or something like that, you might want to step back and scratch your head and say, yeah, maybe I did something wrong mathematically. Let me check my math, make sure I don't have a decimal point in the wrong place or something like that, because that's kind of out of whack a little bit. So that's the typical numbers that we'd see, and that's how we calculate that. Relatively simple, relatively straightforward to get that compression ratio.